Lab 3, Mass of a Black Hole. Introduction. In this experiment, two computational models were created in GlowStrip. One was a planet orbiting an unknown mass, and the other involved a planet, black hole, and ship. The purpose of the first model was to find the mass of a black hole, and the purpose of the second experiment is to determine the initial velocity a ship would need to have so it can leave a planet, come close to a black hole, but eventually leave. Newton's second law governed this experiment. The mass of the black hole was found to be about 6.9 times 10 to the 33rd kilograms, and the initial velocity in meters per second was negative 1.7 times 7 in the x direction and 5.6 times 10 to the 6 in the y direction. Figure 1 represents a visualization of the first model, while Figure 2 represents a visualization of the second model. Experiment theory. As previously stated, Newton's second law plays a large role in this experiment. This law relates a force an object has to its mass and acceleration. An object's acceleration is caused by any forces acting upon it in relation to its mass. Newton's second law is chosen for this experiment to understand gravitational force and how it affects motion and orbiting. This equation can be rearranged to be given the velocity update formula. This new velocity then can be put into the position update formula to find a new position. Gravitational force is given in the second equation. This gravitational force accounts for all of F net. The total energy the ship has is found in the first formula. The assumptions of the model include that gravitational force is the only component of F net and there are no other objects in orbit of the black holes. Experiment methods. All data for part 1 was generated via a unique seed that was attached to our Georgia Tech emails. Initial position was found to be about 2.94 times 10 to the 12, 2.05 times 10 to the 12 meters, and initial position was found to be negative 2.68 times 10 to the 5th and 1.66 times 10 to the 5th meters per second. Both of these points were found from the unique data found from the seed. From part 2, the mass of the black hole that was put in initially was 6.85 times 10 to the 33rd kilograms. This data was found from part 1 of the experiment. Finally, the initial velocity that was found is negative 1.7 times 10 to the 7, 5.6 times 10 to the 6 meters per second. Experiment part 1. Here we have snippets of code for part 1 of the experiment. We can see a rearranged formula for gravitational force here, initial velocity here, as well as formulas for calculating parallel and perpendicular components of force. For part 2 of the experiment, however, we input the initial mass to be the mass we found in the previous part. Next, the initial velocity are put in here. We can see gravitational force formulas being input in various locations, and velocity update and position update found in these snippets of code here. Results and discussion. The average mass of a black hole was found to be about 6.85 times 10 to the 33rd kilograms. Using this mass and playing around with velocity values, the initial velocity found to leave the planet, come close to the black hole, and eventually leave was found to be negative 1.7 times 10 to the 7th, 5.6 times 10 to the 6th meters per second. Discussion. What does it mean? Net force and rate of change of momentum are mathematically and conceptually the same. However, the rate of change of momentum is something observable and measurable by eye, as you can see an object's acceleration changing. However, you cannot see most of the times by eye the net force and various forces acting upon the object. Therefore, the rate of change of momentum is something visualizable and observable versus net force is something more conceptual and done with calculations. What if? What if we wanted the ship to simply leave the planet but come into orbit of the black hole? What initial velocity would we need? This initial velocity is found to be negative 1.59 times 10 to the 7th, 5.51 times 10 to the 6th meters per second. Conclusion. Model predicted average black hole mass was found to be about 6.85 times 10 to the 33rd kilograms, and the initial velocity to get near to the black hole and eventually leave is negative 1.7 times 10 to the 7, 5.6 times 10 to the 6 meters per second.